Hi, I'm Seshu, founder and CEO of Frore Systems. We are the makers of AirJet, the world's first solid-state active cooling chip. The AirJet is only 2.5 millimeters thick, and for the first time you have a chip that can actively dissipate heat.
And this is really doing some noise in the industry, right? I mean, it's cool, it's silent, but like a lot of people are talking about this potentially changing a lot of stuff, right?
That's correct. It's silent and it's based on solid state, unlike mechanical active cooling solutions like fans. And it's very thin, so it fits into ultra thin compact devices. And it also performs equally well in devices that are dustproof and waterproof. So this is the first time that you actually can have active cooling in sealed enclosures.
It's very important to be dust-proof because then you can have a longer lifespan, right? You can use it for 10, 20 years, it'll be fine.
Yeah, the bane of active cooling solutions has been that they inevitably require the device to have a bunch of holes in it for venting air in and out. When you have those holes, it's not just air that enters the device, but you also have dust. These devices become a dust magnet. So over time, dust accumulates on all your electronics inside the device, and it deteriorates the performance of the device.
And people basically throw their devices out because it's too complicated to clean the dust out of the cooling thing?
That's right. Or they become more and more noisy, and you'll start having memory corruptions and all sorts of performance problems. So it's very important to make the device dust-proof. But it's one of those compromises people have made in the past, because if you want to have a higher performance, then you need a bigger thermal envelope. And the only way you could get that is by including poor active cooling solutions like fans. But the problem with fans is they have very low back pressure, and that means that you need to have a lot of open vents in the device.
So the biggest story here at Computex, other than Frore, of course, is the new launch of the X Elite, X Plus with the Windows on ARM that are going to try to challenge a little bit the amazing stuff Apple has been doing the last 3-4 years with the amazingly powerful ARM CPU laptops.
That's right.
And even though it's ARM, and I thought ARM didn't need the cooling and everything, but actually they're getting so powerful, it really helps to have one of these, right?
Without a doubt. And we are proving that by showing the performance of the Apple products here with and without AirJet in them. This is the iPad Pro. It uses the Apple Silicon M-series processor. The M-series processor is so powerful that when you put this in an iPad Pro, it throttles massively. You're getting less than 50% of the performance of the processor because it's passively cooled, and therefore it can only dissipate about 14 watts of heat. So your CPU can only get 9 watts, even though Apple Silicon M3 processor can give you maximum performance when you deliver it like 20 watts of power.
Because it's quite interesting that Apple launched their new M4 in the iPad before launching in the MacBooks.
Correct.
And
because
if your solution wasn't there, you could totally make the iPad run as fast as a MacBook.
We can make it run twice as fast as the MacBook. You're right. So in order to prove that, we've actually rigged up an iPad Pro here with our AirJets. So there are 2 AirJet Minis right underneath this vapor chamber here. You can't see them, but they're underneath them. And the vapor chamber extends here because the M-series processor is right here in the iPad. And it all fits into a 5.5 millimeter thick device that iPad is. And you can do that because we are only 2.5 millimeters thick.
So you took out something to fit it in, or just fit it in somehow? It doesn't need extra space?
It doesn't need extra space. It doesn't need extra thickness. But we made some extra space by removing a speaker that is currently there. But if you designed it from scratch, you could certainly do it in such a way that there is no compromise of anything in terms of functionality. But we wanted to make a point that by just adding 2 AirJet Minis in the iPad Pro, in the same thickness of the device, you can improve performance by 55%.
That's completely amazing. And it's one of the reasons why iOS is still a thing and they don't just ship this with macOS, is because they basically run their chips at lower speed because they're thinner.
That's correct. Because if you want to run iOS, you need a higher thermal envelope. If you want to run macOS, you need a higher thermal envelope. iOS is a more lighter OS. So therefore, you can actually, it's a mobile OS. So you can deliver very good applications with a lower CPU performance. So there is actually a disconnect. They're using a notebook SoC in iPad because it delivers a higher functionality, but then you're compromising on performance because you're not able to realize the full performance that particular processor can deliver.
This could deliver the dream that I have a little bit, even though I prefer Android and stuff, but to have an iPhone or an iPad have dual mode, where they can have iOS and macOS, full macOS mode, because you would be able to run the ARM chip pretty much at its full potential.
Certainly. If you can feel it over here. So this is actually working right now. You can feel the AirJets pushing out air out of the iPad. It's silent,
Nice.
and it's working, and it's improving the overall performance of the processor by more than 50% without any change in the form factor.
And what happened with those MacBooks over there?
Well, here's another story. This is a MacBook Air. This also has the Apple Silicon M processor. In fact, the same processor that's inside those iPads. But because it's the notebook form factor, it has a bigger thermal envelope, and the processor is running at 11 watt CPU power, whereas in the iPad Pro, it's only at 9 watts. So you are getting a little bit more performance for running macOS, but still, you're leaving a lot of performance on the table because the Apple Silicon M3 processor can run at 20 watts. So, but you're only getting 12 watts of the performance. So what we did is we rigged up this MacBook Air with 3 AirJet Minis without changing the form factor, in the same thickness. The base thickness of the MacBook Air is 7.5 millimeters. So within that thickness, we were able to fit in 3 AirJet Minis because each mini is only 2.5 millimeters thick. And we are able to deliver up to 18 watts, 19 watts of performance.
So that this is the actual jump.
That's right. That's the jump, just by adding AirJet Minis. In the MacBook Air, same thickness, same ID, same form factor.
Is this unmodified MacBook Pro? You're showing that
That's correct. This is unmodified MacBook Pro. So what we are saying is that by adding 3 AirJet Minis, the MacBook Air matches the same performance as a MacBook Pro. And it's the MacBook Pro that you're getting the full performance of the M3 chip. And everything else that's using the chip in other form factors, you're losing out on the performance. And the only reason you're losing out on the performance is because of limited thermal envelope. And we can expand the thermal envelope in these very thin form factors by adding AirJet. And that's basically why AirJet is making big waves in the industry right now.
So basically, these amazing new ARM processors that are optimized for computing
still
they need to
leave
be
performance
cooled.
on the table.
And they have a lot of potential.
They have a lot of potential, especially in thin devices. And we can unleash that potential using the AirJet Mini chip, whereas fans are not an option. You can't put a fan into a 5.5 millimeter thick device. You can't put a fan into a 7.5 millimeter thick base. That's why they don't have fans. But you can put an AirJet and get the full performance.
And it's amazing what you've done without doing official design, right? You are pretty much demonstrating what could potentially happen, but it could be even more once it's optimized design, right?
Absolutely, absolutely. One thing that you get, even though you're adding AirJet to get the higher performance, is that you're not compromising on certain dimensions. It's still silent because the chip is silent. It is still dustproof because you can cover all the inlet and exit vents in the device with dust guards, with dustproof material, so that only air goes in and out, dust does not. And it can also be made waterproof. So you have all these virtues despite making it into an active cooling system.
Is there kind of like a turbo mode where I can use even more power to cool it even more and overclock and stuff like that? Does that make sense?
You could do that.
In theory,
certainly.
they could be.
In theory, it can be done.
So there would be less battery life, but you could encode your 8K videos double as fast, maybe.
Well, it's more battery life, but you can do it faster, right? When you go into turbo mode, it does consume more power.
All right.
Here's a third example, and this is a gaming smartphone that also benefits from adding an AirJet in it.
And so
we
what's the CPU
are showing that you can improve the performance of the CPU by 40% in a smartphone form factor by adding AirJet in it.
What is the CPU going on here?
I'm not entirely sure. It's a mobile CPU. It's a premium mobile CPU. And we are able to improve its performance by 40% by adding just one AirJet Mini.
That's awesome because you can connect a little bit like a switch. You connect it to the big 4K TV and you run like a home console at
That's
full
right.
speed.
But even when you're using it in a mobile device use case, now with on-device AI, with AI models like Gemini for Android, you are requiring much greater processing power. Because if you're running any use case, you're using CPUs and GPUs, and they're still taking up the same amount of processing power. But in addition, now you want to turbocharge that with AI so that you can make the application smarter. So therefore, you need to be able to deliver more power for the CPU to deliver that performance. And you can't provide more power to the CPU unless your system can dissipate the heat that is generated by the extra power. And in order to dissipate extra heat, you need to add an AirJet.
It sounds so awesome, and AirJet, it sounds like a little bit like a rocket science. Is it like some kind of physics that are in terms of aerodynamics and everything?
It is.
What is the science behind?
Sure. This is actually it's a fascinating question, because into this 2.5 millimeters we packed an incredible amount of technology. Inside this chip, we have vibrating MEMS membranes, and they vibrate at ultrasonic frequencies. And as they vibrate, the chip sucks air in through the top, because the vibrating membranes create a huge suction force, kind of like a vacuum cleaner, although it's silent. So the air gets sucked into the chip, and that air is pushed down to the bottom of the chip at very high velocities as pulsating jets. And the pulsating jets reach 200 kilometers per hour in speed. And those pulsating jets of air impinge on the copper bottom of this chip and pick up the heat. In fact, they get saturated with heat. The air gets saturated with heat, and the hot air comes out through the exit on the side.
Maybe right over here you are a little bit illustrating what's happening, right?
Yes. So this is actually what we call the AirJet pack. So this is actually what we've done is, a lot of people want more performance than one chip, because one chip delivers about 5 watts of heat removal. And our customers have been asking us if we could deliver form factors that can deliver more performance. And so what we've done is we've come up with this cartridge concept, where basically we have 5 AirJet Minis inside the cartridge, along with all the drive circuitry that's needed to drive these chips. So it's all self-contained. It's plug and play. So this is a cartridge. It's 6 millimeters in thickness. And because we have 5 AirJet Minis in it, it can remove 25 watts of heat. So if you have a processor that is consuming 25 watts and you want to remove the heat, you can just attach this. See, the processor goes here. So you attach it, and you're done. You got an active cooling system that enables you to build a waterproof, dustproof, silent, thin device that can perform at its full performance without any compromise.
And here you're demonstrating it with the edge computing.
Correct. With NVIDIA's
solution?
edge computing device.
Yeah.
Would you like to see it?
Yeah.
So what you have here is basically a video. We've been able to use a technique called Schlieren to capture how the hot air is exiting the cartridge. So this is a cartridge, AirJet pack cartridge with 3 chips in it. So you can see the exit air coming out of the 3 chips.
Nice.
So it's operating in silence, but there's a strong, airflow that's happening in and out of this cartridge, and that's what you're capturing there.
Nice. So let's have a look at the NVIDIA solution.
Yeah.
Because that's also an ARM-powered solution, and
it
it's
is.
for the edge and embedded
That's
world.
right. This is the NVIDIA Jetson Orin processor, NX, and it delivers 100 TOPS of AI performance, and it consumes about 25 watts of heat. And if you use a fan, this is the kind of form factor that you have. We just put it here for comparison purposes. Now this one is also the Jetson Orin NX, but now instead of this fan-based form factor,
It's really hot here.
You got the AirJet. Yeah, it's very hot. This is an AirJet one. And so by making this with AirJet, it's a much thinner device, as you can see, and it's also silent.
It seems cooler.
It's cooler. It's cooler, it's thinner, it's silent, it's dustproof, it's waterproof. And this device, which is using fan, is none of those.
Because this Jetson Orin is probably kind of powerful, right?
It's very powerful. It is the most popular edge AI gateway processor that's used in many industrial smart city applications, robotics as well. Jensen Huang talks about it in his keynotes about the application for the Jetson in robotics. So by basically attaching an AirJet pack instead of the fan, we've been able to improve the performance as well. So you can see the blue is basically the FPS score that you get with the AirJet pack, and the gray is the FPS score with the fan. And we are beating on every metric the performance of the fan by including the AirJet pack. So it's faster, it's thinner, it's silent, it's dustproof, and it's waterproof.
Nice. And here's another mini PC here.
Yes. This is one of our customers, Zotac. They have a compact mini PC, probably the most compact mini PC in the market today. And originally they created the device with only passive cooling because it's too small to have a fan in it, right? When it's passively cooled, you see it's super hot.
Yeah.
And also the processor is severely throttled. So what we did was we worked with them to include 2 AirJet Minis inside the same form factor. And
Wow.
by including 2 AirJet Minis, we are able to deliver the full CPU performance,
Is it gonna be
and
hot?
it's cooler.
Oh, yeah, it's nearly yeah.
Relatively cooler.
A little bit cooler, right?
Yeah. But the performance improvement you can see, it's gone from like 2 watts to 7 watts.
And so this is some of the latest Intel solution for the mini PC market.
That's correct.
And it just changes the game.
That's right.
Right?
That's right. And here's another one. This is an industrial. This is for the oil and gas industry. It's from a company called Acura, and it's what is called a panel PC that's used on oil rigs. And on oil rigs, it's a very dirty environment, so they have to be dustproof and waterproof. In addition, they have to operate in all sorts of incredibly tough environments. So this has to operate in when ambient temperatures are 45 degrees. When your ambient temperatures are 45 degrees, passive cooling is not going to work because passive cooling works based on the difference of the temperature between the ambient air and the skin temperature. When the ambient air is very hot, doesn't matter how hot the skin is, you're not going to be able to radiate heat. So you need active cooling. So we included AirJets inside, and we were able to show that even in 45C ambient, you don't have any loss of performance. And we did it while keeping the enclosure waterproof and dustproof.
To make your device work, you still need to suck the air from outside, right?
We do.
But even if it's very, very hot outside,
doesn't matter.
You perform better than everything else?
Well, we perform better than not having us. So usually what happens is, a passive cool device will work very well at 25C ambient. But when the ambient goes up to 45, the amount of heat you can remove from the device passively plummets. So then the CPU has to slow down. But if you're putting AirJets in it, you can compensate for the loss of passive cooling with active cooling. The key is to be able to do it while maintaining the device as a dustproof, waterproof device, which means that your inlet vents have to be very small and they have to be covered with dustproof material, dustproof and waterproof material, so that only air goes in and out, dust and water doesn't go in and out.
And if you can stay here for a second, so what's the latest with mass production of your technology, and where are you with that?
The product is in mass production, the AirJet Mini. We have several customers who already launched products with our technology that are available in the market. You can purchase them. And we have a long list of customers who are currently in the process of integrating our technology into their devices. And every quarter you see more and more devices being announced that have AirJet in them.
Because it sounds so new and so special. Is it very hard to make? Do you have to improve your manufacturing systems, or it doesn't matter? You can make millions right now of them if somebody wants them.
We can make millions right now, but the scope and the potential of this technology is that we would be making hundreds of millions as well. It's a matter of time.
A matter of time. And do you make them here in Taiwan also?
Yes, we actually have a fab in Taiwan, in Hsinchu.
And how is it different from everything else? You have to customize manufacturing. This is completely different from everything else, right?
It is.
Or can you just connect with the other businesses that, you know what I mean?
Well,
it's not connected with LCD factories or something like that, or?
We leverage the high-tech industry at large. This is a very semiconductor-ish manufacturing process. So we've borrowed from the incredible amount of knowledge and technologies that already exist for manufacturing of silicon. We also leverage techniques that are used in the display industry for manufacturing, as well as the automotive industry. as well as the aircraft industry. So what we've built is a completely new manufacturing process for our technology and our product that builds on the shoulders of giants, because there's so many innovations that have happened in various industries, and we've been able to synthesize those techniques to create an entirely new manufacturing process for the AirJet.
So just to understand, we're talking about ARM devices, ARM-powered laptops, for example.
And here's Intel.
And Intel also?
Yes.
Because, so which one is this?
So this is the Samsung Galaxy Book Pro. It's the thinnest laptop, Intel laptop in the market today. And it has an Intel i7 processor. And since it's very thin, this one is actually, this has a fan in it. But since it's very thin, the fan is very thin, and the performance the fan can deliver is limited. So it's not as bad as not having anything, but it's still limited. So in this 13-inch notebook with fan, you're only able to run it at around 12 watts of CPU power. What we have done is we've taken the fan out, and we used that space to add 3 AirJet Minis in it. So this is basically what it looks like. And just replacing the fan with 3 AirJet Minis, we've been able to improve the performance from 12 watts to 16 watts. While making it silent, because the fan is noisy, we are silent. Fan means that the device is not dustproof. This device is dustproof, yet delivers higher performance within the same space that is currently used by the fan.
So your product is very well suited to thin laptops,
That's
smartphones, but are you...
And devices that are dustproof and waterproof and silent.
Small desktops, but some of these Intel desktops use hundreds of watts, right? They use a lot. Or servers and cloud and stuff. Do you have a vision there?
We do. I mean, this technology, because we use semiconductor processing technology, we have the ability to continuously improve the performance of our product. So AirJet Mini is just a first generation product. We have this vision that we call Frore's law, where we would improve the performance, heat dissipation capability of our chip every year. We want to double the performance every 2 years. So as we do that, over multiple generations, we believe that these chips are going to get more and more powerful and become even more effective in serving the market.
That's so awesome. So they could potentially be smaller form factors that goes in more smartphones or something. Who knows?
Certainly.
Who knows?
They'll become smaller, thinner, yet more powerful.
Because it's my dream for more than 10 years to have my smartphone as my desktop. Yeah. I want to just dock it in and use like maybe a lap dock, with no CPU inside, but run everything off the phone.
You could, if you improve the thermal envelope of your phone, and using AirJet will get you that.
Nice. Any other demos you want to show here?
Sure.
Yeah.
Here's one interesting one. This is SSD accessory. You have Thunderbolt interfaces now to laptops, which deliver very high data read and write throughput into your SSD.
Is this an 8 terabyte?
This is an 8 terabyte SSD, that's correct.
Did you modify this one?
Well, what we did was we basically put 2 AirJet Minis in it. This one does not have the Minis. This is passively cooled. This one, the same form factor, we put in
It's really hot.
2 AirJet Minis. You can see the difference. When you don't have, when it is passively cooled without AirJet Minis, the throughput is throttling down to 1.2 gigabytes per second, even though the maximum throughput you could run it at is 3 gigabytes per second. By putting 2 AirJet Minis, you're getting the full 3 gigabytes, no throttling.
That's so awesome. So we could eventually get external SSDs that are as fast, or that whatever internal SSDs might be, potentially.
That's correct, because what Intel is doing is developing the Thunderbolt standard to be able to achieve exactly that vision. But you can't realize that vision unless the SSD storage device that you're connecting it to has the thermal envelope to be able to actually run that fast. And you can improve the thermal envelope using AirJet.
Because since my M1 MacBook Air, like from 3+ years ago, I was always thinking, it's so expensive when Apple sells their SSD. I just want to buy external.
Right.
But I could never find anything to maximize my full 20 megabit per second. I can only find 10 megabit on the market, kind of. Now
you can with AirJet.
Yeah. Now 40.
Look for SSDs that have AirJet in them.
30, 40 megabit.
That's correct. I mean, it doesn't matter. You can add another AirJet if you like to get a bigger thermal envelope. And here's another interesting example. This is LED lighting. you know, you have a category of LED lighting called architectural LED lights. These are high-end lights that are recessed in the ceiling. And when it's recessed in the ceiling, you know, you have all sorts of, you know, foam, you know, fire retarding material there. Then that is actually not very good for heat dissipation. So in order to remove the heat that is generated by the LED, you need a big box like this in your recessed ceiling. And inside the box, you have this heat sink. A heat sink inside a big box is what it takes to remove the heat. What we've been able to do is shrink the box by 90% and replace the heat sink with 2 minis.
That's it.
And that's it. And you can run the same LED
Only
light
this.
at full performance.
Wow, that's a big difference.
So it's a 90% reduction in volume, 72% reduction in weight.
Wow, cool. And last year I did a video with your colleague, and there was the whole wall with all these different ideas. And over the last year, has there been more ideas that came?
There are several of them. I mean, we couldn't have a demo for everything we're working on, but the number of devices out there, especially with on-device AI becoming ubiquitous and IoT really coming of age with AI, the potential for, you know, the vast, categories of devices that require more processing in a very small form factor, and as a result require active cooling, heat dissipation, are all potential markets for us, and we're working with several of them.
And what's this demo there?
This is our dev kit. This is what we call the Snow Goose dev kit. When a new category of customers want to try out our product, we want to make it easy for them. So we are selling and shipping this dev kit to them with some AirJet Mini samples so that they can try it out for themselves. And if they like what they see, and if they think that AirJet is a good fit for their product, then they can engage us and we support them for commercialization.
And there's no challenges, nothing, everything just working?
Yes, it is.
Technology?
It works beautifully.
How long has it been in development to get to here?
Well, we are a company that's 5.5 years old. You know, this didn't happen overnight. You know, we not only had to design the product, but build it and then take it to volume manufacturing using completely new manufacturing techniques. So that takes time. So we are 5.5 years old, and now we are, you know, shipping in volume.
And 5.5 years ago, there was nothing about this idea. It just
started
at that
5.5
point?
years ago. It was just me and my co-founder Surya. We started this company, and everything that you see here was built after we founded the company.
Did it take a while before you could demonstrate that your idea could actually happen?
It did. It took a couple of years just to get to a point where we could demonstrate it.
Awesome. All right. Cool. So looking forward to more of this everywhere.
Thank you.